Let's start with the classical view. The classical view, which is the one you're going to find in any textbook made in the last 4 or 5 decades, the hormone, in this case estrogen, goes into the cell through the outer membrane, binds its receptor inside the cytoplasm. They call this a generic nuclear receptor, but this could be an estrogen receptor. And those two estrogen receptors find each other. They dimerize, which is a fancy word for just partnering up. And then they go into the nucleus, bind to the hormone response element, often called the steroid response element as well. And then you have upregulation of many genes downstream. Ultimately, the net effect is the biological activity or estrogenic action of the cell. So this is normal. Estradiol could be out here binding a receptor, or 2 estradiol molecules finding the receptors, binding together. And this happens all day, every day in a cycling woman. Right? So this is a normal reaction. Tamoxifen is designed to bind the alpha receptor out here. So we have alpha and beta receptor variants. And tamoxifen will bind irreversibly to the alpha receptor, which is the one that's implicated in breast cancer. And by binding that, it blocks the estrogen that is in circulation from coming in and binding. So in cycling women with a menses, tamoxifen is the preferred agent because then their own estrogen cannot bind. The net effect of tamoxifen on breast tissue is anti-estrogenic. That's not necessarily true of all tissues. It's strongly anti-estrogenic on breast tissue. Other slideshows I'm going to make will explain exactly how that happens, how it could have different effects in different tissues. Phytoestrogens preferentially bind beta receptors out here, and the beta receptor is much less estrogenic in the first place, and it can have different actions on cells, and it is not as implicated in breast cancer as the alpha receptor. And in fact, data now shows that a moderate serving of soy foods have a net benefit for women on tamoxifen and Arimidex, postmenopausally in particular. Of course, I'm a naturopath, so I'm going to add the word organic to that, but organic was not used in the studies. That's my own bias. All right, for molecular paths to steroidal action, we just did the first one. So this is the classical view, also called the ligand-dependent pathway or direct pathway. We like to put 3 names on everything just to make it more complicated. So here you have the estrogen, it binds the receptor, receptors find each other, receptors bind the DNA, and you have ensuing gene expression, proliferation, packets of neurotransmitters get to be released in your brain so you can think straight and concentrate and things like that. So estrogen can be a nice thing on many tissues, as we all know. A transcription factor binds to the estrogen receptor and DNA. So this is very similar to the classic view, except there's a transcription factor that comes between the estrogen receptors and the DNA. But the net effect is very similar, and that transcription factor then allows the DNA to go ahead and transcribe the RNA, and the net effect is the same. There are also outer membrane receptors, and this gets a little murky. We don't know exactly what these outer membrane receptors are doing. Remember, I told you these are floating around in the cytosol. These are sitting on the membrane waiting for estrogen to come by. And what is happening exactly is still being flushed out. So we're not going to spend too much time talking about that, nor do we know what to do about this one. We assume, because we have net effects of lowering recurrence with tamoxifen and aromatase inhibitors, that the net effect is, we're figuring this out, but it doesn't have a lot of ramifications for decision making in patients from a practical point of view. This last one is important to understand, however. It's ligand independent. So by being ligand independent, it means that estrogen does not need to be around in order for this to be activated. This is an important pathway to understand. We now know that insulin-like growth factor is one growth factor that can activate kinases that phosphorylate estrogen receptors, and by doing this, they go and find each other, just as if estrogen was around. They bind the DNA and then have their estrogenic action. And the reason this is important because estrogen is not around. So in a woman with an aromatase inhibitor whose estrogen is essentially gone, it's 98% reduced on those aromatase inhibitor agents. If the IGF-1 is very high in the bloodstream, there is some risk to activating estrogen pathways, and IGF-1 goes up high with simple carbohydrate ingestion, sugars, flours, things that lead to higher blood sugar. So controlling blood sugar is really important in order to control growth factors in the area. We're going to talk about SERMs in our next segment, and SERMs can be a very confusing topic. SERMs are selective estrogen receptor modulators, and the one everyone is familiar with is tamoxifen.